All right, for Algebra 2 today, we are working on section 5.8, the last one in this chapter, and this is solutions to quadratic equations. So we're going to kind of talk about all the different ways that you can solve quadratic equations, all the methods that we've learned. So one, we're going to identify the best method, if I could underline. We're going to find the best method for solving a quadratic equation. Evaluate the discriminant, we'll look over that today, to classify the nature and number of solutions of a quadratic. So whether they're going to be real numbers or complex, and if there's going to be one, two, or no solutions. 3, we're going to write quadratic equation with a given rational, irrational, or complex roots. Very fun stuff. And 4, as always, solve some real-world applications that involve quadratic equations. So let's dive right in. This chart here, which takes up like all the page, I know, right? We can get it all in there. Okay, these are all the techniques for solving quadratics that we have looked at. So one thing, remember, our quadratic is ax squared plus bx plus c equals 0. That's our quadratic equation. So in our chart, we have the type of technique. So we have factoring, taking roots, the quadratic formula, and completing the square. So not really in the order that we learned them. We have a use when row there, so when we should use these. And then we have our example row, so you can see it worked out. So for factoring, we want to use factoring when we have polynomial, the polynomial factors easily, or if we have c equals to 0. It's a perfect time to use factoring. Taking roots, when b is equal to 0, or the polynomial is a perfect square. So like if we look at this one, we have the x minus 2 squared equals negative 8. Okay, so if we have a perfect square, it's a perfect time to use it. The quadratic, this one is perfect. The previous methods are difficult to use, okay, because the quadratic will solve any, this will solve any quadratic equation at all if we use the quadratic formula. Completing the square is really only, I love this one, when you're directed to do so, like to show me that you can do it. It is that backup. Most people hate that one the most. That's the one where you're adding the b divided by 2 squared. But anyway, so really you only have to do that one when you're directed to do so. The quadratic formula is generally the preferred method. Okay, so we have then to move on to the discriminant. Okay, so when the quadratic formula is used, the value of the radicand, right, indicates the number and type of solutions. Say what? So this value, d for our discriminant, equals b squared minus 4ac. Okay, is called the discriminant. So that's the value of the radicand. So if you think about that, when we have the quadratic, okay, the quadratic formula, we just did that one yesterday, was x equals the negative b plus or minus the square root of b squared minus 4ac, all of that divided by 2a. The radicand is the part, right? It's the value of the radicand. So that's the part under the radical sign. So this is your discriminant that we're talking about. Barely fits on there. That is what we call the discriminant. So this value, okay, tells you the number and type of solutions. So it's really kind of cool. So again, we're going back here. Your discriminant, d equals the b squared minus 4ac. If d is greater than 0, so if it's greater than 0 and a perfect square, you're going to have 2 rational solutions. So if we look over here, here's our solutions. We have 3 halves and negative 1. If our perfect square, our determinant, pardon me, is greater than 0 and not a perfect square, you're going to get two irrational answers. So that's when we have approximately 1.15 and negative 0.65. Okay, so they're irrational answers because we can't find the square root. This one has a square root of 13, and so there is no square root of 13. So right there versus the square root of 25, which we could actually solve. So we get irrational. All right, the next one. If D is equal to 0, our discriminant is equal to 0, we get one rational answer. Those are my favorite, not going to lie, right? Because then you just get the 1/4. And if it is less than 0, the discriminant is less than 0, a pair, so we're going to get 2, right? That means 2, of complex conjugates. Ugh, these are your dreaded ones, right? They're complex. So they're going to have a real and an imaginary part to be complex. So like this one. And there's a pair of them, right? Because it's 1/4 plus or minus 3/4 I. So one answer would be the 1/4 plus 3/4 I. And the other one would be 1/4 minus 3/4 I. You don't have to write it like that, though. You can write it with a plus or minus. So that's kind of helpful to know what our answers on are right away. Gives us a little bit of a shortcut. Or maybe not a shortcut, but helps us know if our final answers are right or wrong. Maybe that's a better way to describe it. Okay, so let's dive in. Example 2 says solve 4x squared plus 49 equals 28x as directed. Okay, so I'm going to look at a couple different methods. A is by factoring, B, completing the square, and C, the quadratic formula. Okay, so with A, let's bring it down here. We have 4x squared plus 49 equals 28x. All right, well, if we remember, standard form is ax squared plus bx plus c equals 0. We don't have that in this formula or in our setup of this equation. So we need to subtract the 28x and move it to the other side. So then we have 4x squared minus 28x plus 49 now equals 0. So now we're set. All right, next problem. We have 4x squared. Could I divide the whole equation by 4 to make this easier? 28, I could divide by negative 28, I could divide by 4. 49, however, I cannot. So remember, we have to take the product of our a and our c. So 4 times 49 equals 196, and then find what factors of 196 equal the negative 28. So I, of course, did some playing before we started and found out it was negative 14 and negative 14. I shouldn't say I did playing, I did some math, right? Because negative 14 times negative 14 will give me 196, and negative 14 plus negative 14 will give me negative 128. Okay, so if you recall, it's been a while, we do 4x squared, then we write our factors. Minus 14x, because remember we split this middle factor into the two parts. Minus 14x again, plus 49 equals 0. Then we insert our parentheses, right? We group our first two together, and we group our second two terms together, and then we factor out of those. Okay, so what do 4x squared and negative 14x have in common? Well, we could take out a 2x, right? So let's take out 2x. 4x squared divided by 2x is 2x, and then minus 14x divided by 2x is 7. Now let's look at the next two terms. Negative 14x plus 49. What can I take out of those? Common factor is going to be minus 7 because we'd like to get rid of this negative number. So I'll take the negative out. Negative 14x divided by negative 7 leaves me with 2x. 49 divided by negative 7 is going to leave me with negative 7 equals 0. Remember, we ultimately want the two terms in here to be the same because then we can factor those out. So we're going to have 2x, the quantity 2x minus 7 times, okay, I can see that yellow, okay, so hopefully you can. Now, the numbers they have in common are, right, the leftover is 2x minus 7. What? That means that this was a perfect square trinomial. We could have used the perfect square trinomial method on it, even, to factor, but we didn't see that. You might have seen it. But so then we have 2x, the quantity 2x minus 7 squared equals 0. And we can square root that. I'm going to run out of room here. So then I just get, so I'm going to move it over here. 2x minus 7 equals 0. Add 7. So 2x equals 7. Divide by 2. And x equals 7 halves. All right, so we just have the one answer, 7 halves. But that was a lot of work factoring to get there. And so unfortunately, I'm going to have to erase some of this work. So we have room to do the rest of it. So if you don't have this down, it's not the end of the world. You can go back and watch the lesson. Or again, we're just kind of practicing to see that no matter what technique we use, we're going to get the same answer. So I'm going to draw an eraser line here so I have some room. I'm sorry, guys. I don't like to cut off the work, but I have to. All right, so if we did this with completing the square. Okay, so we've got the 4x squared plus 49 equals 28x. Since we're completing the square, we want to get, for that one, we want to get the 28x over here, and we want the 49 over there, if you recall. Completing the square, we want the ax squared. Actually, we don't want ax squared. We want x squared. You get in that habit. We want x squared plus bx equals the c over here. All right, so let's swap some numbers around. So we're going to have 4x squared, because we'd have to subtract 28x. So minus 28x, and we'd have to subtract 49. So equals negative 49. Okay, then we can't have the 4 here, so we're going to have to divide everything by 4. All right, so this is going to leave us with x squared minus 28x divided by 4 is going to give us 7x equals negative 49 fourths, because we can't really simplify that at all. And then to complete the square, now we're ready to add the b squared, or b divided by 2 squared. So x squared minus 7x plus, our b value is the negative 7. So negative 7 divided by 2 squared equals negative 49 fourths plus negative 7 divided by 2 squared. So lots of steps to remember here. All right, if you remember too, I'm going to save myself some time and not break this, go ahead and square this, because I'm just going to turn around and do x minus 7 squared, or 7 divided by 2, and square that quantity, because that would have been it. And then equals negative 49 fourths plus negative 7 halves squared. Okay, so let's look at that math. Negative 7 halves times negative 7 halves would have been negative 7 times negative 7. It's positive 49. 2 times 2 is 4. So this is negative 49 fourths plus 49 fourths. So that equals 0. That's pretty glorious. Then we do the same thing we did earlier. We find the square root. We get x minus 7 over 2 equals 0. And so then we simply add 7 halves to the other side, and we get x equals 7 halves, which is what we got the first time. We just had more things like different things, not more, but different things to remember to do. Okay. All right, comes time to erase our work. Again, feel free to rewatch the video if you don't have the notes down. This is just us checking out the differences, seeing them side by side worked out. All right, the last one is the quadratic, using the quadratic. All right, so I'm going to save us some time and go ahead and write it as 4x squared minus 28x plus 49 equals 0, because we already did that step over here, right, in A. That way we can go ahead and identify our A equals 4, our B is negative 28, and our C is 49. Because we need that quadratic formula. Okay, so our quadratic formula. You guys remember that? Is that one you want memorized? For sure. All right, Shirley, you've got it. You've shouted it out for me already, so let's write it down here. So we're going to be using that x equals the square root, or negative b, plus or minus, the square root, that radicand, of b squared minus 4ac divided by 2a. All right, so let's plug our numbers in. So x is going to equal negative b, which is negative 28, plus or minus the square root of negative 28 squared minus 4 times 49. Well, you can't hardly see that 49, so hopefully I don't forget it. Divided by 2 times 4. All right, let me check my work here. Negative 28 plus or minus negative 28 squared minus 4 times 9 times 49 divided by 2 times 4. Perfect. Just wanted to make sure I didn't make any mistakes. So x is going to equal a positive 28 plus or minus the square root. Okay, negative 28 squared is, or let's see, that's just going to be a positive 28. Okay, I lost my place. So yeah, negative 28 squared is 784 minus 4 times 9 times 49 is 784. I love when that works out. Divided by 8. So x equals, okay, so 28 plus or minus the square root of 0 all over 8, which is just 28 divided by 8, which is 7 halves, once again. Okay, so you have lots of options. So don't think you have to do it one way or another unless you're specifically told. Some of you may love completing the square. Others of you may love the factoring. Somebody else might like the quadratic formula. It is totally fine when you are given a choice to do whichever one you want. Okay. Now, example 3, we're going to look at this discriminant idea, which if we look at for a second right here, right, when we got to this point with our discriminant, okay, 784 minus 784, that's what we just talked about on the front. If your discriminant, or no, I'm sorry, did we talk about that yesterday? Right, that was yesterday. Using, hold on. No, that was today. I'm losing my mind because I haven't taught yesterday's lesson. I just looked over it. But if you use the discriminant, it will help you know what your answer is going to be. So, good stuff there. I like it. All right, so let's look at example 3. Hope I didn't confuse you with the discriminant stuff, right? Because this is what I was talking about. If our discriminant is equal to 0, we get one rational number. That's what I was going to show you, okay? So we got our one rational for that problem, and it was 7 over 2. So that was a quick check, like, did we do it right? Yeah, we got one rational solution, so we probably did our problem correctly. Okay. Example 3 then. says use the discriminant to determine the number and nature of the solutions to each equation. So we're not actually solving, okay? We're just using that discriminant. So for A, I did it for us. Okay, so we've got 3x squared plus 5x plus 8 equals 0. So I highlighted my A is 3, my B is 5, my C is 8. Here's my formula for the discriminant. That's b squared minus 4ac. So I plug my numbers in. 5 squared minus 4 times A, which is 3, times C, which is 8. So I got 25 minus 96. And so D equals negative 71 on the front of my notes, okay, that we just looked at again. The solution, if I would flip it over, but here, let me grab another note sheet because I don't want to mess that one up. Okay, so our D is negative 71, so D is less than 0 down there. We're going to have a pair of complex conjugates. Okay, that's what this says, a pair of complex conjugates. So our number is a pair, so 2, and the nature or the type is complex conjugates. That's all we're looking for here. So let's do B. All right, so we've got 4 over here, which we can't have, so let's subtract the 4 from both sides. Then we are left with 12x minus 9x squared. Oh, I just now realized those aren't even in the right order. So let's reorder them. So we need to have negative 9x squared plus 12x minus 4 equals 0. Okay, and so our A is negative 9, B is a positive 12, and C is a negative 4. Our determinant equals B squared. So we've got 12 squared, if my pen would work again, minus 4 times A, good, negative 9, times C, excellent, negative 4. So our determinant equals 12 squared is, awesome, 144. And then we have, let's see, negative 4, negative 9, and negative 4. So we're going to have a negative answer. So that's why I went ahead and put that there. 4 times 9 times 4 is 144. So our D equals 0. What does that tell us? If you look back at the front chart, when D equals 0, what does that mean? Good, we're going to have one rational solution. We're going to have one rational solution. Excellent. All right, our last example. Let me clear it so we can move up a little bit. So now we're going to rewrite, or pardon me, not rewrite, we're going to write a standard form quadratic equation with the given solutions. Okay, so remember, we have to reverse the steps. Okay, if we have one solution, we use the corresponding factor and twice, pardon me. So if there's one solution, we use it twice. If it's imaginary or a rational solution, we just reverse the steps used to take the roots. Okay, so we've got an example of both of those here. So if we look at the first one, here we have one solution, 2/3. So we're going to use the corresponding factor twice once we get there. Okay, so, all right, so we have x equals 2 divided by 3. So first I multiplied by 3, okay, to get rid of the denominator. So now I have 3 times x equals 2. I want it to be 0. I want to get my factor. So I subtract 2, and now I have 3x minus 2 equals 0. Now is that time we're going to use that corresponding factor twice. We're going to take the 3x minus 2 and we use it twice. So we have the quantity 3x minus 2 times the quantity 3x minus 2 equals 0. That's the only way we can do, like if we have one solution, it's because they were matching, they were identical. Okay, so now that we have this point, we have to FOIL. So 3x times 3x is 9x squared. 3x times negative 2 is negative 6x. Negative 2 times 3x is negative 6x. Negative 2 times negative 2 is a positive 4. We combine like terms. So negative 6x minus 6x is going to give us negative 12x. So there is our standard form quadratic equation. 9x squared minus 12x plus 4 equals 0. So we took it from our roots, our solution, remember it was x equals 2/3, and worked it backwards till we got here. So let's try that now with, this is a complex number, right? Because it says imaginary or rational, that would be complex, a compound conjugate, and let's work it backwards. Okay, so first thing we need to do is we've got the 5 over here kind of by itself. We're going to subtract the 5 so we can get rid of our imaginary number. So x minus 5 equals plus or minus 2i times the square root of 7. Okay, so we've got our radical term there. Now we need to square it, right? Like that's how we get rid of it, is we square this. Okay, so let's take this part and square it, and we're going to take this part and square it. So we're going to have x minus 5, squared equals, okay, if we square this, let's think about it. We're going to have 2 squared is 4, I squared is negative 1, the square root of 7 squared is 7. Okay, so we squared each part. Again, 2 squared is 4, I squared is negative 1, the square root of 7 squared is 7. Okay, I'm going to go ahead and, so then we're going to have the quantity x minus 5 times the quantity x minus 5 equals negative 4 times 1 times 7 is negative 28. We're going to go ahead and factor, or FOIL, pardon me, x times x is x squared, x times negative 5 is minus 5x, negative 5 times x is negative 5x, negative 5 times negative 5 is a positive 25, and that equals negative 28. Okay, I'm going to add 28 to both sides to get it to be equal to 0. And I'm going to add like terms in here. So we're going to have x squared minus 10x plus 53 equals 0. All right, so now we have our standard form quadratic equation. Done. All right, so today is really a review day. Like the discriminant part is new, but the rest is like reviewing all the strategies back and forth. So do your best on your homework. Go back and watch the lesson tonight. If you're confused, it will be up on YouTube. So if you need to go back and watch it, go back and watch it, finish up your notes, whatever you need to do. But it really is reviewing all of the strategies we've learned until now so you can put them into practice and be more prepared to do that. All right, I will see you guys tomorrow night or tomorrow.